Hello, Algebra 2, and welcome to Lesson 3.2, Part 2. We're going to be adding, subtracting, and multiplying polynomials again. Our essential question is going to stay the same, except for now, we're going to go ahead and apply these to some application problems. And we're going to start with one about Carolina. She's making some wind chimes. What we need to do is we need to find out how many wind chimes Carolina would sell in order to maximize her profit. And this is kind of a tricky problem, I think, in some ways, just because there's a lot that we need to figure out. Luckily, we've been given this. So that is essentially our hint. What we need to do is we need to set up an equation for profits. We need to figure out what is our revenue and cost. So revenue minus cost. So first thing we need to do, let's figure out how to calculate revenue. It tells us that this relates the price V to the number produced, right? So if we look at this, V of X equals 48 minus 2X, what this is saying is that we could find out the price of one unit. Let's look at that, right? V. So if X is 1, if we have 1 unit, then the price of 1 unit is going to be 50. I believe $50, I think, is what's going to go on here. All right, so what that's telling us is that one of them is $50. But what we'd like to know is how much, how much is made if she makes one. Well, she would make $50, right? But what would happen if, so let's look at V of 2, okay? So what she's saying is that if she is creating only 2 of them, then the price that she would sell them at, and I'm sorry, that's subtracting there. My bad, that should be 46. So in this case, if she makes 2 of them, the cost that she would, the amount that she would sell them for would be $44, right? So the idea is that the more of these wind chimes that she makes, the lower she is able to, the lower she is able to charge for them, or the lower price she's able to charge for them. So that's interesting. So this is the price of wind chimes depending on how many she has made. But what we really want to know is revenue. How much does she make? All right. So what we'll do is we'll go ahead and we'll take this, and now we'll talk about the revenue. I'm going to make a new function, revenue. And check it out. If I was to multiply this by X, right? So look, we're going to say that she's going to make 2 of them, right? Well, if she made 2 of them, then we'd have to multiply it by 2 as well in order to find out how much money she makes, right? We know how much she sells them for, right? This tells us how much money she sells them for. This is telling us how much money she makes. Because if we were to look at that, right, at R of 2, so she sells 2 items, right? We put this 2 in here to figure out the cost, and then we multiply it again by 2, so we figure out how much she makes when she sells 2. So it looks like we have our revenue equation, which is going to be this R of X equals, in parentheses, 48 minus 2X, close parentheses, times X. So let's go ahead and see if we can create some sort of, so a profit. That is going to be equal to, we'll just write profit for now. And our revenue, we decided, was going to be X times, just moving the X out to the front of that, 48 minus 2X. This tells me how much money she makes depending on how many wind chimes she makes. Now, the wind chimes cost can be modeled by 12x plus 64, right? So if she makes one chime is going to cost her $76 to make. So it looks like we have our revenue minus cost, right? So revenue minus cost here. Let's go ahead and simplify this, and this will give us a function that will give us our profit. How about this? Let's call that P of X, okay? P of X. Let's go ahead and simplify this and get what P of X is. So X times 48 is 48x. X times negative 2x is negative 2x squared. We're going to have to distribute this negative sign as well. So that's going to be minus 12x, right? Minus 64. Let's go ahead and combine like terms. So I've got a negative 2x squared. Looks like this 48x and 12x can be combined because they are like terms to give me a 36x, and then we'll drop down the 64. Fantastic. So we have a function that represents our profit. Now, if I was to think about the graph of this, it looks like this is going to be a parabola opening down. And what we want to know is the maximum, right? We want to maximize our profit. So if this is a function that models our profit, we would like to know what is the maximum value of this function. And it's really nice because we can find that out simply by graphing. So let's get out our handy dandy calculators. All right, and there's mine. Let's go ahead and graph our function for profit that we came up with, negative 2x plus 30, sorry, and that should be 2x squared, shouldn't it? There we go. And that should be plus 36x minus 64. Let's graph that thing. And perhaps we'll need to zoom out a bit, especially because we can see that our Y-intercept is negative 64 on this. So let's go ahead and zoom out a bit. I'll like to zoom out from the origin. Oh, well, we're fairly close. Here we go. Ooh, still not there. Let's zoom out again. All right, there's our max. We would like to know where that is, so we can use our calculator to find that out. Remember how to do that? We would hit second trace. That gives us our calc. We would like to know what the maximum is on this. So it asks you, hey, where are we looking? And you're like, in between here and here. And then I guess that it's, at the top. And it says that our maximum is at x equals 9, y equals 98. What does that mean in terms of our question? We said in this question that x, right, x is the number of wind chimes produced, right? So how many wind chimes should Carolina sell each week to maximize her profit? The answer would be 9 wind chimes. And what would her profit be? It would be $98 a week that she's making. Fantastic. So let's go ahead and answer the question. She needs to sell 9 wind chimes. Nice. Awesome. Let's do another one. So in this question, we'll be comparing two polynomial functions, and we're going to find out some information about these two companies, I guess, if you will, with the flower pots, and we've got Carolina's wind chimes. There it is. We graphed that earlier using our graphing utility. What we want to know is the y-intercept of each function. We want to know who would lose more money if neither person sold any item. So we know from looking at the graph here that Carolina, right, when x equals 0, Carolina is going to lose $64, right? Because we're outputting our profit, right? So Carolina is going to lose $64. That's not good. All right. If she sells 0 items, but uh, how about our flower pot person? We'd like to know what is the y-intercept of this particular function. And in order to find that out, all we have to do, right, to find our y-intercept, what do? We will let x equals 0, right? Because uh, everywhere on the y-axis, x equals 0. So we plug in x equals 0. We should know where this touches the y-axis, or what is the y-intercept. So r of 0 here in this particular function is going to tell us what the y-intercept is, right? Well, if we simplify all this stuff, right, -3 times 10, well, we're multiplying by 0, right? So we know that this is automatically going to be 0. So we know that when this gentleman sells flower pots, that if he sells um, 0 flower pots, he makes 0 money. While unfortunately for Carolina, if she sells 0 wind chimes, she loses $64. So we would say that Carolina will lose more money. Fantastic. And that wraps up this particular lesson. Thank you so much for watching. I hope you're having a fantastic day. And if you're not, I really hope it gets better. Take care of yourself.